Hello and welcome to our channel. Learn at 7:30 p.m. with your friend. In today's class, we will discuss the first chapter, Relations and Functions. In this chapter, we will discuss introduction, types of relations, functions, types of functions, composition of functions and invertible functions, binary operations, and of course, the problems related to these topics. In your previous class, that is in class 11, uh, we have discussed or learned sets, different types of sets, relations, domain, codomain, range, and so on. So, what do you mean by a set? You know that a set is a collection of well defined objects. For example, let me write a question. A set A is equal to set 1, 2, 3, 4, and 5. You know that the elements will be included or elements will be listed within two curly brackets, and each element will be separated from the other by a comma. Okay, so this is a well defined collection. You know that these are the natural numbers less than or equal to first five natural numbers, or the natural numbers less than or equal to 5. Another way, these are the natural numbers less than 6, and so on. So it's a well defined collection of objects. Now, then you know that different types of sets like non-empty sets, empty sets, finite and infinite sets, and so on. And you discussed relations also. And for a relation, you need two sets. For example, say set A and B. And from A to B, you can define relation. From B to A, you can define relations. And you know that what do you mean by a domain, what is a codomain, and what is a range, and so on. All these things we have learned in class 11. Okay, now before moving to the chapter relations and functions, we have to recall certain concepts also in detail. Let us see. The first one is ordered pair. So, what do you mean by an ordered pair? You know that an ordered pair is a pair of objects, or there must be two objects. A pair of objects listed in a specified order. There should be a specific order for this. Or in other words, how can you define ordered pair? A pair of objects listed in a specified order is called an ordered pair. And these objects will be enclosing in the in brackets. Okay, so these objects will be enclosed within brackets. It's also very important. Now, how can you say that two ordered pairs are equal? For example, one ordered pair is say AB, another one we will take it as CD. So how can you say that AB and CD are equal? Say AB is equal to CD only if A is equal to C. It is only if A is equal to C and B is equal to D. Otherwise, you cannot say that AB and CD are equal. So, do you think that AB, ordered pair AB is equal to BA? No, AB is not equal to BA. And one more thing, AB is equal to BA if and only if A is equal to B. Then only you can say that ordered pairs are equal. In other words, you can say 2 3, ordered pair 2 3 is not equal to 3 2. But what is the difference here? So if you have a set, say set 2 3, another set 3 2, these sets are equal because for the case in the case of sets, we do not mention or we do not bother about their order. But for an ordered pair, there should be some specific order. Okay, we'll take another example. Suppose it's given that ordered pair AB is equal to 5 negative 2. So what do you mean by this? This means A is equal to 5 and B is equal to negative 2. Okay, so A is equal to 5 and B is equal to negative 2. That is why ordered pair is defined as a pair of objects listed in a specified order. That is why it's called an ordered pair. And as I told you, two ordered pairs AB and CD are equal only if A is equal to C and B is equal to D, and AB is never equal to BA, I mean AB is not equal to BA, and AB is equal to BA if and only if A is equal to B. So I think it is very clear. An ordered pair is a collection of two objects separated with a comma and enclosed within brackets. Okay. Now the next point is Cartesian products of sets. This also I think we have already discussed in class 11. So what do you make Cartesian products of sets? For this, let us consider two non-empty sets. Say A is equal to set 1, 2, 3. Okay, a small set, and we'll take another set. B is equal to, for convenience, I'll take say A and B. Okay. So what do you make Cartesian product or cross product of A and B? So I think you remember A cross B is equal to set. That is, we have to choose first element from A and second element from B. So the first element, I mean, first ordered pair can be 1A. Okay, Cartesian product. 1A, next one is comma 1B. Then 2A, comma 2B, and third one is, okay, I'll write here 3A, comma 3B. So this is the Cartesian product or cross product of A and B. So A cross B is equal to 1A, 1B, 2A, 2B, 3A, 3B. So you can see that the first element, for example, the first element of A cross B is ordered pair 1A. So you have to notice that each element of A cross B is an ordered pair. See, each element is an ordered pair. Here, each element is a single number or a letter. But whereas in A cross B, each element is an ordered pair. So there is a comma inside the bracket and between two elements. So let us consider the first element. See, 1A. So what is the specialty here? The first element 1 must be from the first set and second element A from the second set. So in other words, we can define A cross B as A cross B is equal to those AB such that A belongs to A and B belongs to B. Or A cross B is defined as ordered pair, set of ordered pairs A B such that small a belongs to capital A and small b belongs to capital B. So in A cross B, each element will be an ordered pair. So this is the Cartesian product of sets. And okay, have you remember the cardinal number? For example, suppose consider set A is equal to A, B, C, and D. So what is n of A or the cardinal number of A? So n of A means number of elements in A. Here there are four elements. Let us consider another element. I mean B. B is equal to say x comma y. So what is here n of B? N of B is equal to 2. So in n of A is equal to 4 and n of B is equal to 2. So how many elements in A cross B? Let us see. We can say AX, yeah, AX, AY, then BX, BY, CX, CY, DX, DY. So you can say n of B or n of A cross B is equal to 8. There will be 8 elements. You can write and see. Or in other words, n of A cross B is equal to n of A into n of B. Number of elements in A cross B is equal to number of elements in A into number of elements in B. This also, I think we have learned already in class 11. Fine. So now you know what is an ordered pair. So what do you mean by Cartesian products of sets, and how can you find the number of elements in the Cartesian products of two finite set? So if A and B are two finite sets, then n of A cross B is equal to n of A into n of B. Clear? Now, for example, let us take number of elements in the Cartesian product of two sets. Let's take an example. Given n of A is equal to 5 and number of B is equal to 3. How many elements will be there in A cross B? It is very simple. N of A cross B is equal to n of A into n of B. which is equal to 5 into 3, which is equal to how many? 15. So one more question I want to just ask you. If n of a cross b is equal to 15, how many subsets are there for a cross b? So let us recall, if number of A is equal to number of elements in the set A is equal to 5, there will be 2 raised to 5 subsets for A, isn't it? N of B is equal to 3. Here n of B is equal to 3. So how many subsets are there for B, set B? Yeah, it's very simple, 2 raised to 3. You know this because we already learned. Now, n of a cross b. If n of a cross b is equal to 15, how many elements will be there? Or how many subsets are there for a cross b? It's very clear. There will be 2 raised to 15 subsets. Okay. So you can say if n of a is equal to some m, then there will be a raised to m subsets or 2 raised to m subsets. Okay, sorry, 2 raised to m subsets will be done. Clear? If n of a is equal to 10, n of b is equal to some 3, how many subsets will be therefore n of how many subsets will be there for a cross b? You know that n of a cross b is equal to 10 into 3, and of course it is 30. Therefore, how many subsets will be there? Subsets will be 2 raised to 30 subsets. 2 raised to the power 30 subsets will be there for this A cross B. Clear? Now, let us see the next topic, relation. Shall we take two examples? For example, x is equal to, I'll take a small example, 2, 5, say 7, and say y is equal to 5 and some more number 9. Okay, so we have two non-empty sets, say x is equal to 2, 5, 7 and y is equal to 5, 9. So shall we write x cross y, the cross product, the Cartesian products? Okay, so 2, 5, write in order, then comma 2, 9. Next one 5, 5 and 5, 9. Then 7, 5 comma 7, 9. So these are the elements of x cross y. Let's see here. Here there are 3 elements. Here there are 2 elements. So 3 twos are 6 elements. Let's see. 1, 2, 3, 4, 5, and 6 elements in x cross y. Now, um, I want a relation. I'm going to define a relation. Say uh, R is equal to set AB, ordered pair AB, such that A is lesser than B. So what is the meaning of this? We need a relation R is equal to AB, or we need all the ordered pairs of the form say AB such that the first element A is lesser than B. So how can you list that relation from here? So whenever you are writing a relation, we need two non-empty sets, say here x and y, and the relation is defined from x to y. Relation is from x to y. That is, first element must be from x and the second element must be from y. So if the relation is from y to x, we have to write y cross x, not x cross y. Remember. Now here the relation is a must be less than b, or the first element must be lesser than the second element. So shall we write 2, 5 is obey the rule. So 2, 5, 2, 9, comma must be there. 5, 5 can we write? No, 5 is equal to 5, so we cannot write 5. So what about 5, 9 we can write because 5 is lesser than 9. 7, 5 can we write? No, you cannot because 7 is less greater than 5. But we need the first element must be smaller. So 7, 5 we cannot write, but we can write 7, 9. So according to our relation, according to our definition of the relation, these are the ordered pairs which obey the rule. Okay, these are the ordered pairs which are obeying the rule. Okay, fine. 2, 5, 2, 9, 5, 9, and 7, 9. Why we didn't take 5, 5? Because both A and B are equal here. So it is not equal to, here equal to sign is not there. A must be strictly lesser than B. Here 7, 9, 5, but here the 7, 5 is, what about 7, 5? Here 7 is greater than 5, but according to our condition, first number must be lesser than the second element. Fine. So this is the relation. Now you can see that if you write all the subsets of x cross y, how many subsets will be there for x cross y? Here there are 6 elements. Therefore, 2 raised to 6 elements will be there for this x cross y. Now, if you write the subsets of x cross y, you can see that this R is also a subset of x cross y. R is a relation, of course, and a relation from x to y, it is a subset of x cross y. So, in that sense, how can you define a relation? How can you define a relation from A to B? So, if A and B are two non empty sets, then a relation R from A to B is defined as a subset of equal to A cross B. Why I wrote here equal to? Sometimes all elements of A cross B may satisfy the condition. In that sense, you can say R is equal to A cross B. Let us discuss a question like that. So, how can you define a relation? A relation for any two non-empty sets A and B, a relation R from A to B is defined as a subset of A cross B. Okay. Why this equal to sign? Let's take an example. Again, A is equal to set 1, 2. That's all. And B is equal to set 5, 6. Simple. So what is A cross B? A cross B is equal to, as you write, ordered pair 1, 5, 1, 6. Next one is 2, 5 and 2, 6. So here I'm to define a relation. R is equal to those AB or XY, whatever you want to take it, AB, such that the condition is A must be lesser than B. First element must be lesser than B. So let us write that relation. See, 1 is lesser than 5, so you can write 1, 5, 1 lesser than 6, so you can take 1, 6 also, 2, 5, and of course 2, 6 also. So you can see here all the elements of A cross B, all the elements of A cross B satisfy this condition, say A is lesser than B, or in other words, this relation is equal to A cross B. That is why all relations are either a subset or equal to A cross B. Okay. Sometimes none of the elements of A cross B will obey this rule. In that sense, R is equal to 5, or there won't be any element in our R. In that sense, we can call R is an empty relation. So R is an empty relation. If the number of elements in R is 5, or if R is equal to a null set, you can say it is an empty relation. We'll discuss with more questions. And if R is equal to A cross B, we can say that R is a universal relation. Understood? So, what do you mean relation? For any two non-empty sets A and B, a relation R from A to B is defined as a subset or equal to A cross B. Sometimes there will not be any elements in R. In that sense, that such a relation is called an empty relation. If R is equal to the complete set A cross B, then you can say R is a universal set. Okay, so this is the just an introduction, and we have to discuss different types of relations, different kinds of different types of relations with examples, and how can you identify range, domain, codomain, etc. All these things we will discuss in the next class. Thanks for watching. Thank you.